This is a completely modular mousetrap car. In this one kit, it can create thousands of possible configurations for your students to build. They can be built for speed or distance. About any challenge you do with a traditional mousetrap car, you can do with these cars. So in this video, I'm going to show you how these kits work. I'm going to show you how to put these cars together, how to bring them into the classroom, and some tips and tricks I learned along the way. My name is Nathan Van Zanny, and welcome to Catching Steam. I built these mousetrap cars in a way to where they're almost entirely 3D printed. Now with that said, there are a few parts that you just can't 3D print. So one of them is being a mousetrap. You're also going to need some string and 4 zip ties per group. Any kind of tape is helpful, like masking tape. It's not mandatory, but it is helpful. And the last part that is going to be probably the most difficult to source are these 1/8 inch steel axles. They are 1/8 inch by 1/8 inch by various lengths. If you have a Vex Robotics program, you already have these axles. Now, if you don't, not a big deal. They're really inexpensive. I bought them in 3-foot sections from a website called Mousetrap Car for only a few dollars. I just had to cut them into 2 4-inch lengths and a 9-inch length. If you already have these and they're other different sizes, don't feel like you need to cut them to these lengths. This is just what I use to optimize my 3-foot sections. So 2 4 inches and 1 9-inch per group. Now, when you're done cutting them or finding somebody to cut them for you, I just sand off the edges so they're not sharp. So you can put them on a sander, hand sand them. Just make sure these aren't sharp for students because I don't want them to get cut. Now, those are all the non-3D printed parts. So just a mousetrap, steel axles, cable ties, tape, and string. Now to get to all the 3D printed pieces. The first part I'm going to recommend that you print is going to be this slammer arm adapter. It's meant to hold this slammer arm in the center of your mousetrap. So you're going to put 4 zip ties, your cable ties, and you're going to zip tie it onto the slammer arm of the mousetrap. Now, after you have that part made, you're going to make the body. Now, this I recommend printing like this on your bed. And there's 2 main reasons. One, I want these holes that the axles go into, I want them to be really smooth. If there's a lot of support material in there, these axles are going to rub on there and create a lot of friction, and they're not going to work very well. The second reason I want you to print it like this is for the direction of those layer lines. If you print them like this, these little pieces are going to break off. So printing it like this is going to make it a lot stronger, and it's going to make the axles work a lot more effectively. Now with this mousetrap car body, you're going to take your mousetrap and it just slides right into the side like that. Now at this point, I recommend putting a little bit of hot glue right on the edges, and that's just going to make it so the mousetrap doesn't easily fall out. Do not put a bunch of hot glue on it, just in case this mousetrap breaks. I want you to be able to take it off without having to reprint everything else. So I recommend having an extra mousetrap available with the slammer arm adapter already on it. So when these break, you can just slide on a new one and then deal with the slammer arm on the broken one. After this piece, you are going to need your slammer arm, and that's going to get attached in here. Now that you have a mousetrap on a body, you're going to need some wheels. So I printed an assortment of wheels for you. They're ranging all the way from 50 millimeters all the way to 150 millimeters. And I put them in 25 millimeter increments. So 75, 100, 125, 150. I might even put some larger sizes on there for you if you'd like. I put a couple of features on these wheels that you're probably gonna like, and feel free to make your own sizes as well if you want. But the first is there's a square hole in there. So it fits this axle and it doesn't allow any slipping. So if this was a cylinder, if the size wasn't exactly right from your printer, these would probably start slipping with wear. Now with the square axle and the square hole, you don't have to worry about that. Another feature I did is I put how large the diameter is of the wheel on there. So this, it's gonna be hard to see, but it says 50. This one says 150. And like I said, I have them everywhere in between. And it's pretty straightforward to put these wheels on. You just slide the axle through here. Put one wheel on and then the other. So now you can see these two spin really well, even though it's a square peg and a round hole. And now you'll need some front wheels, so you'll do the same thing here. This car is almost finished. You're just gonna need to connect the string to the back axle. So there's this part here, and this, you just tie a string to it, and then that's gonna slide right onto this slammer arm. This other side, you can tie it or tape it, whatever you wanna do, and right to this back axle. At this point, these cars should be ready to test. I wanted students to be able to test the length of the arm. Now, you don't actually need to change the physical length of this arm. It only really matters where the string is getting pulled from. So if you have the string down here, it should go really fast but not go very far. If the string is clear up here, it should go a lot further and a lot slower. Two problems with this though that it had to fix. The first problem is the tension from the mousetrap was adjusting the length of the string when I didn't want it to. So students tried to put tape on it, but the tape wasn't holding very well with how strong that force was from the mousetrap. So what I figured out is to use these spacers that I designed. They also have a square that fits right over here, and they are a set length. So now you can slide however many spacers you want on this mousetrap. And then when you put this string attachment on, no matter how hard this gets pulled, it won't slide down that rod anymore. But my next issue was, as my students started adding more and more spacers, it should have been going further and further and further, but it wasn't. But then I had to go back and realize, why do mousetrap cars go further when you extend the length of the arm? And the reason is because how much string it takes, right? Well, the amount of string only matters if it's getting wrapped around that back axle. And that was my next issue. Now I'm going to take this wheel off so you can see this, but if you look, this string is now lined up with that back axle. But now you can imagine if this string is getting pulled from all the way back here, you can see there's all this string right here not getting wrapped around the back axle. To optimize the placement of this string should be clear over here. So for students to actually be able to test how the length of the arm influences speed and distance, I not only have to change the length of the arm, I have to be able to move these back axles back, which as of now, I can't do. I did figure out a way around that, and that involves these extenders. So how these work is you just take these back axles off, or the back axle off. These extenders slide right over the body. At this point, you'll be able to put this back axle wherever you'd like. So let's say I want it right here. And now I just add the correct number of spacers, put my string attachment back on, and this can align perfectly with that back axle. So now all the string that's getting pulled back with the mousetrap can get wrapped around that back axle. The length of each spacer is the same distance between each of these. So if I want to move my axles back one space, I just have to add one more spacer. Now the last part I printed is because of the issue of this. And this just slides right over those two extenders just like that, kind of acting like a bumper, but it's really just a spacer. So even when I squeeze these two in, these parts don't flex anymore. Now this is going to be a pretty good distance car. I will say the furthest my students have gotten these cars to go are about 35 to 40 feet, and that's going to be on hard tile floor. If you want to build more of a speed car, rather than putting rubber bands on everything, there's a couple options you can do. One, you can just go on carpet if you have carpet somewhere. Another thing that works really well are these drawer liners. It's basically just a rubber mat. I found the cheapest one I could find, and these have nice traction on it, so you're really not going to get any burnouts with this. Another thing that you can do is you can add weight to the wheels. So you can get these 3/4 inch washers, and they fit really well onto the wheel. So if you add more of these, you can really weigh down that back axle and preventing those burnouts from happening. Another benefit of this wheel design is it prevents this part of the wheel to rub on the body of the car, so there's a lot less friction. If you were to flip these wheels around this way, there's going to be so much friction that they're going to stop a lot quicker. So definitely don't do this, but students should be able to figure that out pretty quick. Hopefully that is enough for you and your students to be able to comfortably build a multitude of mousetrap cars, whether you're going for speed or distance. Maybe you just want students to be able to record data or to look at independent, dependent variables. Now, I want this to just be a start though. I don't want this to be the end of the modular Mousetrap Car Kit, because I know there are so many more pieces and so many more ideas out there. So if you have any of your own, or if you have any other challenges that you really like, make sure you comment down below and definitely subscribe, because I'm going to have a lot more of this content coming up. There's going to be a future video where I go over multiple challenges that you can do with these types of mousetrap cars or the traditional kind. I really hope you enjoyed this video, and thank you very much for watching.